So we are talking about TCP IP. TCP IP stands for the Transmission Control Protocol Internet Protocol. We already talked about this. It's a DoD model, Department of Defense model, and this was created by the DoD, the US Department of the Defense. The reason behind creating the DoD model was, as we already told, like it was to prevent the network was created so that in case of any disaster, natural or man-made disaster, any war situation also, the data is safe at multiple locations, and at the same time data can be saved or data can be utilized at multiple locations. That's why the DoD model was created. That is what we call as a TCP IP. Now it's very important, again I'm saying, you need to understand it very properly. You have to concentrate it properly. Do not miss a single word what I'm saying. Okay, and as I told you, I'm recording this also. You can use it forever. Like this TCP IP is something which is not going to change. The concept is going to be same. There will be no changes in this. It is since whenever the network started, since then the same thing is there. So in TCP IP, first of all, we have got two versions of TCP IP. One is IP version 4 and one is IP version 6. Two versions are there, IP version 4 and 6. The IP version 4 is 2 power to 32. It has got 2 power to 32 addresses. So if you calculate, it is billions of addresses, 2 power to 32. Whereas IP version 6 is 2 power to 128. So you can assume that how much 2 power to 128 will be there, right? If you calculate, it will show infinity like that. So why we have got IP version 4 and why IP version 6? What is the major difference? First we'll see. The IP version 4 and 6, as you can see, the number of IP addresses are huge in IPv6, right? Whereas compared to IP version 4. IP version 4 was there since the beginning of TCP IP, and we know IP address is like a telephone number. Every machine in your network will have the IP address. Like every person, if you got a mobile phone, you got a phone number, and that phone number is unique in your country. Nobody else will have the same phone number, whatever the phone number you are having, correct? You cannot have two people with the same phone number, right? So what happens similarly in one network, we cannot have the same IP address as the other person. Now here, sorry, if two persons are having same IP address, then you'll have conflicts. You'll have a lot of errors. It won't say that this IP address, sometimes it will say duplicate IP address, sometimes it won't tell you. So that is there. Now in IP version 4 is 2 power to 38. First of all, IPv4 is written in decimal format. It means like 10.1.2.3, like this, decimal format, or 123, 4, 5, 6, like this, in a decimal format, and which is separated by a dot. There are 4 fields. As you can see, there are total 4 fields in the IPv4, and they are separated by a dot. 10.1.2.3, 123.4.5.6, 7.8.9.10. These are separated by a dot. Every field is known as octet. Octet means 8 bits. When you have 8 bits together, it is known as octet. So we have got 8 bits together, and every octet is representing decimal value. In fact, it is in binary. So whatever we write here, if I am writing 10, it's actually in binary. If I am writing 1, it is in binary. If it is 2, it is in binary. We are writing in decimal. We are a human being. It will be difficult for us to remember the binary, one total 32 bit of binary number. It will be difficult. So for us, it has been converted into decimal. But your computers, your electronic devices, they are using bits, 0 and 1, right? So it's in octet, 8 bits together, and the value is converted. Now we'll see more details there. Now IP version 6 is 2 power to 128, and it's in hexadecimal. There is a hexadecimal values are there, and they are total 128 bit. It means they are between 0 to 9 the values are between 0 to 9 and A to F, and they are separated with a semicolon or double semi like this. These are the notations. Whereas we have got IP version 4, which is in decimal value and divided into 4 octets. Got it? So IPv4, IPv6 we will be seeing later. Later part will come to that. Currently we will concentrate on IPv6, IPv4. Now IP version 4 was very good in still working. People still use it. So why IP version 6? The reason behind that IPv4 has got 2 power to 32. Out of that also, lot of IP addresses already being used. Lot of IP addresses are excluded for many reasons. We'll see that. So what is happening that now we know IoT, Internet of Things, right? So what happens in IoT? You have got your devices which needs the IP addresses. Like one person is having one phone also, and currently population of the world is approximately, so let's say 8 billion, right? On average, many people have one phone, many people don't have phone, many people have 4 phones. On average, there is, you can say, 8 billion phones all over the world. The IP, I'm the phone with the IP addresses. 8 billion phones are there. It means what? Everyone needs some IP address. Got it? They need some IP addresses. Then at the same time there are web pages. Everyone is having some web pages, and at the same time we have got the uh, IP devices, IoT. For example, now your air conditions, your refrigerators, your car, your tube light, all these devices also need the IP address in future. I mean, everything is going to be more IoT, your home security, everything will be going to be more IT or IP savvy, we can say. In that situation, the IP version 4 was not enough, to accommodate all the IP addresses. I mean, to accommodate all the devices which needs the IP address. For that, IP version 6 was created, 2 power to 128, that in future, for next 100 years also, if the world population grows in the same way, it might go to 16 billion also, then also every person can have 2 to 3 IP addresses and it will be enough. So that is why 2 power to 128 was introduced. Still there, both the things are, you can have both the IP addresses on your machine, it will work. But we start with the IP version 4 now. Now, TCP IP, when we are configuring, there are 3 major components we have to configure. Three major components are there. Whenever you're configuring, there are 3 major components we have to configure. So first is known as IP address. Now, what is IP address? IP address is the definition of IP address, if I say, it's a unique identification number assigned to each and every device on a So IP address is basically, it's a unique identification number which you have assigned to each and every device on the network. Now, the structure of IP address is, it's a 32-bit binary number divided into 4 octets. Basically, it's a 32-bit binary number which is divided into 4 octets. All right. So, sorry. So it's a 32-bit binary number which is divided into total 4 octets. Octet means 8 bits. So it's like this. If it's like this here, let's say as you can see, total 32 bit. They are total 32 bit number. So this is 8 bits, this is 8 bits, this is 8 bits, and this is 8 bits, total 8 bits. Right? Now if you convert this value, So this will be 192, this will be 240, this will be 224, this will be 248. Right, 192.240.224.248. This is the IP address we get in the decimal. Right, how to convert, all of you know, right? Binary to decimal, everyone knows, but I'll just show you. What you have to do, you'll write 2 power 2 7, 2 power 2 7, 2 power 2 6, 2 power 2 5, 2 power 2 4, 2 power 2 3, 2 power 2 2, 1, 0. Total 8 bits. This is 128, 64, 32, 16, 8, 4, 2, 1. So what we have to do, we have to just write the, so this is 1 1 0 0 0 0 0. So multiply the values. So 128 multiplied by 1 is 128, 64 by 1 by multiply 64, the remaining are 0, right? This will give 192, correct? Similarly 244 are 1, so 192 plus 32 plus 16 will give you 240. This way we can convert binary to decimal, any number, right? Now this is total 8 bits are there. So this is the structure of the IP address. It is unique identification number. Now unique means no two devices will have the same IP address in the network. That is why it has to be unique. No two addresses will be same. Now after this, we have got second component, which is known as subnet mask. So what is subnet mask? We can say subnet mask definition, if I have to write, I'll write definition as so it will define which part is network, which part is subnetwork, which part is host. In any address, say for example, you write an address, let's say you write an address this is one address. If I write any address, right, just a random address. Now here we know that what is the name of the person, what is the house number, what is the street, right, or building name or street, or the location, the city, the pin code, the country. Every field is predefined. We are human beings, so we know that if I write this address like this, so we know always we write the person's name at the top, then in a sequence we write, right? Or you are writing some form, you are filling some form on computer also, so it will take only specific fields. In person name you cannot write 49, right? You cannot write 49, it will not accept, because the schema will be defined like that, that it has to be give the characters, not the numbers, right? Similarly, what happens now, because we already doing this since our childhood, so it's not new for us. Now, if a person who doesn't know anything, suppose a person from some country or some location, they don't know the addressing scheme or anything like that, and if you give this address to him or her, and if they look at this, they won't be able to tell, right, what is this for. If you say this is the address you have to reach, so they don't know. If they don't know the city name, they don't know the person name, so they don't know what is the format, how I will start, right. So subnet mask tells you in the IP address, where is the, for example, we see the IP address, like for example, if this is the IP address, this is one IP address, let's say, here. Now currently, suppose you don't know anything about, by looking at this, you don't know. So you are like a person who doesn't know anything how the address is written, right? If any person who doesn't know, because we are human being, and since childhood we know that this is the way address is written. But if a person who doesn't know anything about this, that person will be confused. They don't know what to do. Similarly, this IP address, if I tell you don't know anything about IP address, you won't be able to tell what it is written, correct? You don't know where is the network, how it will go, because actually computers are using it. Your network, your LAN card is using it. So you don't know. As a person, you really don't know here, right? Until unless we'll discuss this and we'll show you how it is done. So that is defined by the subnet mask. Out of this, where is the network? Where is the subnetwork? Where is the host? Now, if you look, say, network will be always on top. Under network, you have got the subnetworks, right? Correct? Under subnetwork, you will be the host, right? So it's a hierarchical structure also, if you look into this, isn't it? Like for example, UK is the network, you can say. London is a sub-network. In that, East Ham, River Street and Byron Avenue, they are also sub-network. So you can have multiple sub-network. Then this is the host, correct? In UK, there will be many other cities, Manchester, Birmingham, you know. Then again, in that also you might have multiple locations. Multiple location will multiple street have multiple buildings. Multiple building will have multiple flats or houses. And but then finally there will be, in house also there will be multiple people. But there will be one person who will be unique. Got it? So how this is defined? We have got an addressing scheme. We have already defined this is the country, this is the city, this is the state, this is the city, like that. Similarly, the subnet mask defines, by looking at this, it will evaluate. It is going to compare the IP address with something known as subnet mask. Out of that, it will tell this is the network part. So when a device is going to send some message or send some packet to a destination, what it is going to do? It is going to look at network first. In network, it will go to subnetwork. Again, in subnetwork, there will be another subnetwork, and then it will go to the host. So how does it do? By it will compare whatever the subnet mask is there. It will compare. So subnet mask will tell first is the network, second is the network or subnetwork, third is network or subnetwork, last is host. Always like that. So there are different subnet masks are there. Default subnet masks are there. 255.0.0.0. These are the subnet masks, the default subnet mask. You always compare the IP address with the subnet mask. When you compare the IP address with the subnet mask in conjunction with the conjunction with your IP address, the subnet mask will tell you that this is the network portion, this is the host. Now, usually what happens, wherever there is a, see, always the first octet will be always 255. In subnet mask, it cannot be any other number. If there is any other number, that is wrong. If there is any other number, that is totally wrong. Got it? Getting my point? If any number there is in the first octet except 255, it is wrong. Subnet mask is incorrect. Now, why we have got 0 and 255? Because all the numbers in a binary in 8 bits will be either all 0 or all ones. These are the possibilities, like maximum, minimum 0 and maximum all ones. So all 0 means 0, all 1s is 255. That is why your IP addresses, they always fall between 0 to 255. Okay, the IP addresses, they fall between 0 to 255. Now the subnet mask will be always 255. Now here, if this is class B, I will tell you the classes later. 252, it means what? The first 2 octets. Now if this is, let's say, uh, and I write, and if I say subnet mask for this is 255.255.0.0. In this case, what will happen? It will compare your communication, it will compare 255 this portion, and this will say this is the network. This will go as a host, sub network. This will go as host. Got it? Now let's say in this case, this portion is the first 3 octets, they are the network. This is the host. Got it? So network means, see, 192.1.2. This is same for all the 1, 2, 3, 4, 5, 6. Network is same. Like for example, all the people living in UK, they will be writing UK as the network, I mean their main country. Got it? Now let's say another example. For example, you have got this is the subnet mask. In this case, 255. So network is 11. In network 11, this is the subnetwork. This is network. This is the subnetwork, and this portion is the host. Got it? So we see, even if you don't know, like as a normal user, you don't need to understand. But as a network engineer, you need to know this, right? Whatever, say, if you are writing something wrong, your system is not going to accept it. It will say it is wrong, right? But as an engineer, as an network administrator, you should understand that why this is written here, why this is not here, so that while troubleshooting, you will be able to understand if the system is not accepting, machines are not communicating. So you'll understand, okay, because it was written by so and so like this, that is why it is having the issue. This is clear to all of you. What is the IP address and subnet mask? Okay. Now subnet mask can be changed. This is the default subnet mask. We can customize the subnet mask. When we say we can customize the subnet mask, it means what? That for creating the subnet, we have to customize. This is the default. For example, this is the default one. But we want to create sub-networks. Why we need to create sub-network? Yesterday we discussed, to control the broadcast. Because all the machines in one network, they will be having same broadcast. Suppose you got 100,000 machines and they are in one network, single network. All of them will be getting the same broadcast. That will create huge traffic. So for the better administration, for security, I will create multiple sub-networks. Like for example, you got one country, you haven't divided your country into states or cities, right? There is no proper addressing. Everyone is living and there is no addressing. What is going to happen? It will create a chaos, right? For example, there is no addresses. All you are living, this is location we are saying, but there is no scheme, like there is nothing known as address. Just imagine a country of having, let's say, 1 crore people or 10 million people are living in one country, in one region. There is no address. There is no address at all. Only people have name. Okay? Only people have name. What will happen if you want to go to a certain person? You are going to ask every person, are you so and so? Right? So one person is going to ask 1 crore people or 10 million people, right? So you can understand the chaos. That is why we have got the addresses. We divide the zone, right? We divide the states, we create the states, we create the cities, isn't it? Then we have got the cities, the districts, we have got the I mean location, then we have got the blocks, sectors. Why? So that we can find the person properly, isn't it? So broadcast is like there is no addressing, then it will have to broadcast. So that is why we divide. So when we divide our network into sub networks, the reason behind that is that we are controlling the broadcast. That is the reason. Now this is the default subnet mask we are having. We want to customize it. Why we want to customize? We want to make sure that all the people have got, all the machines have got proper addresses, so that there will be no broadcast storm will be not there. Is it clear? So we'll see the how to create the subnets and everything. Now the third component which we need to know or which we need to configure is known as default gateway address. Default gateway address. What is the default gateway address? Now let's see. Remember yesterday we talked about the routers or the routers. Okay. Then we talked about the switches. In the switches we have got computers. The switches are connected to the router, and then routers are connected like this. You got the computers connected here on the switches. This is a router 1, let's say. Let's say this is router 2. Okay. Now here what happens that they have got some IP addresses. They have got addresses. Let's say they have got address 10.0.0.10. This is 10.0.10. This is let's say 20. This is 30. 10.0.0.20, 10.0.0.30, 10.0.0.40. And this is having some IP address, let's say 20.0.0.10. This is having 20.0.0.10. Let's say this is 20, this is 30, this is 40, like that. So what is happening? It means what? They are divided. The switch are not connected. They are connected by using the router. It means there are different sub-networks. There are different subnets are there. If 10.0.0.10 wants to communicate with 40, it will go to the switch. The switch is going to do what broadcast? ARP, right? Yesterday we talked about the ARP, isn't it? So ARP also Wireshark, you can see that ARP, who is it asking the IP, right? So what happened that ARP broadcast does, and it creates the MAC table or the bridge table or the switch table. It gets IP and MAC. So every time, next time if someone wants to connect to any other else, so it knows that this is the MAC address and it will give the MAC and they will communicate. But if someone from here 10.0.0.10 wants, say I want to communicate with 20.0.0.30. So what will happen? Switch doesn't know anything about where is 20.0.0.30 because it is not in the same network. It will calculate by subnet mask that it is in the same network or not. Like for example, we are in this one room sitting. So whenever we are communicating, we are easily communicating. I can call your name and you can call my name and we can communicate. You can call to the other person, you can communicate. But if any one of you wants to talk to someone else in the other class, other room, what you will do? You are going to use the gate. You'll open the gate and go there. Your gate is like a router. The interface, this interface to which this subnetwork is connected, this is the default gateway address for the full network here. Here also we'll have some address. Let's say it has got address 10.0.0.1. Okay, now gate has to be the part of the room, isn't it? You cannot have gate outside the room. Similarly, the IP address here of the router to which your network is connected has to be the part of the same network. If I want to go to that room, so I have to use this gate, right? If I am to go to the second floor, some room, I have to use my gate to go outside. If the gate is not in my room, I will be not able to go outside, isn't it? Now we are human beings, we know we need a gate, we can go from here. But computers, devices, they are blind, they just follow the instruction. So if you give your gate is this, and actually the gate address you have given wrong, what will happen? It will be never be able to go outside. Got it? It will never go, it will be never able to go outside. So that is why we have got the gateway, default gateway address, which will be the part of the, if you give a wrong default gateway address, two machines in two separate network won't be able to communicate. Two machines in two separate networks, they won't be able to communicate if they are not in the, if you are given wrong address. So many times when you troubleshooting, you will see you are not able to connect any machine on internet or any machine outside your network. Why? Maybe default gateway address is not correct. It means you are not able to go outside, your machine is not able to go outside because of the wrong configured default gateway address. Is it clear? So default gateway, here also now this will be, let's say 20.0.0.1. This will become the default gateway address for this full network. So whenever anyone wants to go outside, it will go to the default gateway address directly, right? Default gateway is a router. Router has got something known as a routing table, which we will learn in more details, in more depth. So how the routing tables are created, how if you give a wrong route, what will be the consequences, everything we will be seeing that. So router 1, let's say this is router 1 here, R1. What is going to happen, that this R1 or the router 1 is your, will have routing table. How to reach us? So this will say 10.0.0.10 will say, I want to go to 20.0.0.30 or 20, let's say 30. It says I want to go here. It will, the request will go to the router. Why? Because it will identify this is not in the same network. If I say I want to talk to, let's say Amit class C, and this is suppose class C, okay, and Amit is here. If I say Amit class C, so Amit will give me response and we will communicate. If I say Amit class D, so Amit is here also, but there might be another Amit in the class D. Got it? So it means what? My request has to go outside the gate. It will be not inside this particular room. So what will happen? My request will go to the router. As soon as I say class D in my example, so if I say here 20, so it will know this 20 and 20, they are not in the same network. So it will go to the router. Router will have the routing table. It knows how to reach at the destination. It will use this link and take to router 2. It will say 20.0.0. I have got a person 10.0.0.10. He wants to communicate with 20.0.0.30. So the router will pass that to the switch. Switch will find this 20.0.0.30, and then 20.0.0.30 will respond to the router, and then the communication will establish on the same link. The router will create a bridge for them to communicate. Okay, so we can, if the router is a gate, we can close the gate also for security, right? Anytime we can disable that this IP address will be not allowed. We can create a firewall on the router, right? We can make router as a firewall. We can use it as a filter that this IP address will be not allowed. This country will be not allowed. This network will be banned, right? Or this will be allowed. Everything we can do on the router. In more details, you will see in the networking part. Got it? So these are the three major components you have in the network. Is it clear to all of you? Any question? Sorry? All right. Now, so these are the three major components we discussed. Now, the IP addresses are divided into class. Now this you need to remember, and by the practice or by remembering, however, this is very important. So class, there is a range. How you will define that? What is this class? Every class has got a default subnet mask, and in every class, the addresses are for network, so that is known as network bit. host. There are 5 classes, class A, B, C, D, E. If the value of the first octet, let's say, if I say w dot x dot y dot z, in this w is the first octet. Okay. So whatever the value of the first octet, whatever the value we write in the first octet defines the class. It will tell that which class it belongs to. This IP address belongs to which class, that is defined only by looking at the first octet value. You need not to see anywhere else. Only look at the first octet. You should be able to tell the which class it belongs to. Now, if the value of the first octet is between 1 to 126, it is 1 to 126. It is class A. If it is class A, the default subnet mask is 25500. It means what? The network portion is the first octet is the network portion. It means what? You have got 2 power to 8 is the network. Host is 0.0.0. It means how many hosts you are getting? 2 power to 24. Because there is here only 8 bits are given to the network. Here 24 bits are given to the host. So in class A network, we can have 2 power to 24 hosts in single subnet. We can have maximum 2 power to 24. That many IP addresses we can use in single one subnet, one network. Got it? Now, if the value of the first octet is between 128 to 191, it is class B. In class B, the default subnet mask is 255.255.0.0. So the network portion is 255.255. So it means what? 2 power to 16 is for the network. So you can have up to, see here you can have 2 power to 8 network. It means what? In class A, we are going to have maximum 2 power to 8 network, right? But host, we have 2 power to 24. Similarly here, host will be 16-bit only and network will be 16-bit also. Class C, any address between 192 to 2 192 to 224, no sorry, 223 is class C, and the default subnet mask is 255.255.255.0. It means what? 2 power to 24. You have got 2 power to 24 networks, and all sorry, this will be here. You got 2 power to 24. Then you got 0, 2 power to 8. Okay. Now class D starts from 224 to 39. Class D is multicast address. We already discussed what is used of the multicast, right? We got unicast, multicast, and broadcast. So class E for the experimental. So we use only class A, class B and class C in the internet on the network. D and E is not used. We don't give these IP addresses to any machine in the network. Okay, it is clear. Now here also you will see 127 is not there because 127 in the first octet is invalid address. It is known as loopback address. Loopback address is for self-testing. Your IP address, it's a local host. So every machine will have the address 127.0.0.1. You cannot give 127 in the first octet. It is not allowed. Okay. So this is clear to all of you. This you have to remember. This table you have to memorize. Okay. Now it means what? Whatever we saw in the classes, it means what? That you have got the value of every octet is predefined. The value of first octet will be always between 1 to 120, sorry, 223, except 127. In the first octet, we cannot have the 127. In first octet, we will not have the 127. Okay, we'll have only between 1 to 223. The value of second and it will be always between 0 to 255. Okay, so this is the rule. By the classes, it has been ruled that the value of the first octet will be always between 1 to 223. There will be no 127 in the first octet. It will be always between 1 to 223. It will be not, you will not have the 127 in the first octet. Now, value of second, third, fourth octet, it will all start from 0 and it will go up till 255, the maximum, because in one octet you got, it could be all 0 or all 1. So if it is all 0, you get 0. If it is all 1, it is 255. This is clear? Now, we'll come to the subnet part, how to create subnets. Now we have got a network. Network has got network ID, it has got a subnet ID, it has got a broadcast ID. Let's say for example, India is a network. So all the people in India, they will write their country or the address and they'll write India as a network. Now India has got many states. The states are created based on the language criteria. There's the minimum criteria for the language, right? If the people who are speaking this much language, so this language, so they are from this state. So the state has got a state ID, correct? You got state, you got country ID, you got a state ID. After that, you have got, so we'll assume that you got a country and state. Similarly, in TCP/IP networking, you got a network ID. Network ID is fixed. Like all the people who are living in any state of India, they are going to write India as their country. Similarly, all the machines in the one network, they will have their network ID fixed, which cannot be changed. Then you got the subnet ID, like your state ID. Similarly, you got the subnet ID. Subnet ID will be same for all the people in one particular subnet. For example, you are in Telangana. So all the people in Telangana, they will have India, Telangana like that, right? their name, then Telangana and India, isn't it? So it is fixed, it cannot be changed. So the subnet ID and the network ID is there so that the router can go to that ID, that address. And from their router, as I told you yesterday, that it works like a post office and postman. So they go to the post office, they deliver the packet, they deliver the mail, and from there the postman will come and divide and go to the postman will work like a switch, we can say. It will collect the addresses, collect the letters, look at the address and deliver it. And router is like just going to the main post office. It will not go individually to the host. It will not go to individually to the people, right? It will just go to your main post office. The router will work like a post office and the collector of the post office, whose job is just to take the and receive and send the letters at a post office. From there it will be given to the switch to deliver. Got it? Is it clear? So what happens that when we are having our network ID, it is fixed for all the devices in the network. Subnet ID will be fixed for all the devices in a particular subnet. Is it clear? So we have to find the subnet ID. Network ID is fixed. We have to create the subnet. So once you create a subnet, this is the subnet ID. We can assume subnet ID as the main grand post office in the state. Got it? All the letters will come there. From there it will be distributed. Right? Every state has got, suppose, a GPO, grand post office. So all the letters will go, if it is coming for that network, that particular state, it will go there. Similarly, the subnet will have a subnet ID. That IP address will be used by the devices to reach there, and from there it is going to be distributed. Then in the end, we have got a broadcast ID. Broadcast ID in the network is 255. This is the by default the broadcast ID. This address, it means if you are sending a message on this address 255, 255, 255, 255, it will be broadcasted to each and every device on a network. It will be reached and it will be sent to each and every machine on the network. This is the default broadcast ID, but this is the broadcast ID for the full network. Then we have a broadcast ID for the sub network. Like for example, any message coming from, let's say, Delhi. There is a broadcast from Delhi, your Prime Minister or President is sending a message. This is for everyone in the country. That is the broadcast message. Then there is a subnet broadcast. Your state chief minister or governor, they send a message. That is only for the state. So you got a subnet broadcast ID also. You got a network broadcast ID. You got a network ID. You got a subnetwork ID. Is it clear, the concept? Everyone okay? Right? Now, what we are going to do, we are going to do some calculation, very interesting calculation. So be very, you might have done in the college with the and or method. This is a different method. You might find it easy or hard, I don't know, but this is the method I use. So what happens that you are a network administrator, right? Your job is to create subnetwork, to divide the addresses properly and everything like that. So what happens that when you design, usually when you go in your organization, your work, so you will see that there are already, everything is predefined, everything is already configured. But it doesn't mean that you don't have to know the basics. You know how it is configured, what is the design. So in case you have to design a new network, or you should understand how it is created. For that we need to understand the subnetting very well. You have to do it properly. If you know the subnetting, I repeat again, you will become the master in the networking. 50% at least you can very easily, anyone can, if you understand the subnetting, how the IP addresses are given and everything. So I believe that up till here, whatever is done is perfectly all right with everyone, right? This concept is clear. If you repeat this video 3-4 times, and whatever the assignment I'm going to give you, if you do it properly, so and as you will be in your field also, you will be in the touch of networking. So this will become like, you'll be very easily, you'll be able to see the network, you'll be able to troubleshoot, you'll be able to find the problems also. You'll be able to create a network, design a network, implement a network very easily, if you understand this concept. You should know what is IP, what is subnet, what is default gateway address. This thing we have done. The classes and everything we have done. Now, the tough part or interesting part comes. Now, what happens? Let's say your administrator, your boss, your manager, they have given you one network ID. They tell you that this is the situation, this is the network ID 75000 we have purchased. Now, there are two types of addresses, public and private. The public addresses are for internet. You have to purchase them from IANA. We have to purchase it. We have to pay for the public IP addresses. Okay, we have got registrars like GoDaddy. You have heard GoDaddy, right? GoDaddy, Big Rock, Big Daddy, all these things are there. They are registrars. Net for domain, they are registrar. What happens? We want to book a domain name. What happens? We pay the money. So that money is for the IP address, right? That money is actually for the IP address. You have given a public IP address with the name also. So what happens that the public IP are costly. In your network, let's say you got 1 lakh people working in your company. You will not buy 1 lakh IP addresses for them. It will be very costly for you. So you got something known as private IP addresses. The private IP addresses are reserved. Those addresses anyone can use in free. Any organization can use the private IP address in free. You need not to pay anything for that. It is already there in different class. Okay. The private IP address is already there. The private addresses will be used inside your organization. Inside the organization, you got the private IP addresses. The reason that you got the private IP addresses, so you need not to purchase it. So you have divided your network and you have configured your network. Now you are creating the sub networks like that. Okay. So let's say we have got the range of the private IP. In class A, you have got it is 10.0.0.0 to in class B, it is 1. These addresses are fixed addresses, the private address, they are blocked. These addresses you will never find on the internet, right? So what happens that in any organization will use any numbers between them inside their organization, right? Now, but what happens that, let's say you have got these computers and let's say I'm using this inside my organization. Let's say this is your organization, all the computers are here and they are using the range of, let's say, class A, and it's between 10, all of them are 10.0.0.0. This address they are using inside the network. But when they go outside to internet, internet is having what? Public addresses, right? The public addresses are on internet, and like this is Google, this is Yahoo, this is Facebook, all the servers are there where you are connecting to the internet. They have got the public addresses. Or you are connecting to any other organization. Let's say you are HCL and you are connecting to Control S. Control S also using this range, the private. All the machines are using private. Got it? Now what happens when you are communicating here, you are using this range, they are communicating, they are using this range 172.16.00 only. Got it? Now, but what happens that if a machine, let's say this is a machine 10, 0, 0, 10. It says that I want to connect to google.com, whose IP is, let's say, 7, 8, just for example, 9.10. So 10, 10, 10, 0, 0, 10 cannot go outside because it's a private address. So you got a router here. So you request, you go to DNS and everything we already know, right? It go to DNS, DNS resolve the name to IP. So the router here will also, we got a server which is on NAT, Network Address Translator. The NAT address or NAT server, what it will do, it will got a pool of IP addresses for your company, your corporation will have a pool of IP addresses which is public. So what will happen, it will give, it will request will come from 10.0.0.10. It will stop 10.0.0.10 here. It will make itself as a public IP and router will reach here and to 7, 8, 9, 10 it will tell, for example, it is 4, 5, 6, 7, that is a network, public IP. So it will come here, it will say, I am 4.5.6.7, I want to talk to 7.8.9.10. Now both are public, both are the public addresses. So they will communicate. Now when the data will come to 4, 5, 6, 7, which is here on the NAT, NAT will again know that 4, 5, 6, 7 is actually 10.0010. So it will give it to 10.0010. Got it? That is a function of a NAT server, Network Address Translator. Got it? We can configure our router as a NAT also. We can make a NAT, we can create a pool that this range is for the routers. So anyone coming, any private address is coming, the public address will be given to them. You'll have a bunch of public addresses, maybe 100 or maybe 10 like that. So your ISPs, for example, when we connect, if you look at your phone IP address, it will be public, private IP address, 192 something like that, right? If you check your phone IP address, you know how to check your phone's IP address? How you can check? You can go to settings and you can find. Usually you'll see this will be a, like for example, if I open settings of my phone and go to, let's say, system, I can see my security. Okay, if you go to your network, like Wi-Fi, for example, if I open my Wi-Fi, in Wi-Fi, if I open, I can see my, or if I'm using the mobile, I mean mobile network, if I open that, also I can see my IP address. Let's say I open Wi-Fi here, and if I open my Wi-Fi, in that I have got my network. If I click on network, whatever network I'm connecting on my Wi-Fi, it will show me the IP address. It will be usually the IP address will be your, the IP address will be in the class C. Usually it's class C. If you look at the settings, and in that you'll be able to see the IP address of your network. So if you check the IP address, it will be, you know, DNS and everything will be there. So it's a private address. So your ISP has got a tool, sorry, NAT address pool is there, NAT, Network Address Translator. Now what happens that, so private IP addresses are here, the ranges are here. You have to know the private IP address ranges also. You'll never find it on internet. Now, yes, huh? No. NAT server and DHCP server are different. DHCP server gives the IP address. It could be DHCP server, could be your private address also, public address also. But NAT server will, you should have an address first. Then only NAT address will translate that, Network Address Translator. DHCP server gives you IP, you don't have any IP address. You get one IP address. Now you want to go outside. So your address, the NAT is going to give address to that IP address. It is going to translate the address which has been given to you by DHCP server. It is going to translate that into public and will get the data, and then public to private it will translate. So actually your IP address is given by DHCP and it has been translated by NAT. Okay. Private to public and public to private. It has got a pool. NAT server will have a pool. So whatever the IP address it has got, then we have got something like PAT, port address translator. Now what happens that, let's say for example, in your network there are 20,000 people and all of them are using internet continuously. So you are not going to have 20,000 public IP address for them. You might have 3-4 IP addresses, and then you are going to use the ports. The port number, as we know, are 1 to 65,536. Out of that, so port numbers, out of that 1 to 1024 are fixed. We cannot change. Okay. Then you can use the address from 20,000 or 30,000 onwards. So one IP address, multiple ports. Let's say you can have IP address. I can give, let's say 192.168.1.2, and I write a port number. Let's say port number 20,001. Port number you write like this, and so on. It means for the same IP address but different port numbers. It means what? The IP address will be same for multiple machines, but port number will be different. So in the IP also you got the port. So you got a PAT, port address translator. The port address translator, what it will do, it is going to translate the, with the IP address, because you got public address limited. Public IP address limited are there. Suppose you got only 10 public addresses, but we have got 20,000 people. So with one IP address, we can give to 10,000 people with the different port numbers. The port number written like with the colon after the IP address like this. Is it clear? So again, the PAT and NAT, they will work together. The NAT will give the public IP and PAT will add the port number into that. Got it? So now here, let's say our network administrator has given us a class A address. They say, okay, this is the address, and we want, let's say, number of subnets. 10 subnets we want. Now why 10 subnet? Maybe geographically they are in different locations. Maybe department wise you want to create different subnetwork for any reason. Subnet, why we want to create to subnet? We want to control the broadcast. That is the first reason to have the subnet. The main reason to have the subnet is you want to control the broadcast. Is it clear? So you want 10 subnet. You have designed that, okay, we have 10 departments or 10 buildings or 2,000 users or 10,000 users. We already know we want to create a subnet. So there is a formula. You get this idea. Now this is your network ID. This is your network ID. And this is a desired number of subnets. You got this situation, you got this information. So there is a formula 2 power to n minus 2 is greater than or equal to number of desired subnets. The n is the value of n, whatever we get, it is number of bits to be masked. When I say masked, it means what? 0 will convert as 1 and 1 will convert as 0. Right? This is only mask. So here 2 power to n minus 2, this is 2. What is the desired number of subnet? 10. What will be value of n? If I put 2 power to 0, it will be 1. If I put 2 power to 1, it will be 2. If I take 2 power to 2, it will be 4. If I take 2 power to 3, it will be 8. If I take 2 power to 4, it will be 16. So value of n I will take as 4. Got it? The value of n I am going to take as 4. This is clear? All right? Upper, yeah. Minimum, see, this is equal or higher, but not less. I want 10 subnets. Say I have got 10 people to sit in this room. So I have to buy the chairs. So I have got option. They are giving option. Either you can have 2 chair, or you got 4 chair, you got 8 chair, you got 16 chair. What will take? 16, right? Although 4 and the remaining will be wasted, but you will not say I will take 8, 2 people is standing. You are expecting 200 guests, right? So the hotel is telling you we have got option of 100, 150, 250, 350, like that. So you will not say, okay, let's give 150, 50 people will be hungry. You will take more, but not less. So we want 10 subnet. It could be more than that, but not less than that. So that is why I take n is equal to 4, right? So this is the 4. 4 is the number of bits which we have to mask. Now where we are going to mask it? Let's see. Now what is the network ID? We have got 10.0.0.0. What is the default subnet mask for this? 255.0.0, right? It means what? If I convert this value, if I convert this value 255, so this is the value I get, right? Now this 4, whatever we have got, we have to convert the first available 0 from the left hand side into 1. The first available zeros in the left hand side as 1. So how many? See, this is 1 is already there. You cannot do any change in the network ID. It is fixed. Now these are the first. After the first octet, we have got the second octet where we have got the zeros. We have got 8 zeros, and we have to convert what? How much bits we have got? How much bits we have got? 4. So we are going to convert 1, 2, 3, 4 as 1, 0 to 1. The remaining will be same. Now if you convert this value, it will be this. This is known as the customized subnet mask. This is known as the customized subnet mask. Got it? This is your customized subnet mask. It means what? You got a network ID and they got the default subnet mask. We have customized. Now in the customized subnet mask, you can see by converting we got 240. This 240 is customized we have done. Now we have got something known as base number. The base number is always 256. Why 256? Because all the values in any octet is between 0 to 255, right? It means what? The total number are 256. 0 to 255 is 256. So what we have to do from the customized subnet mask, the value which we have customized, you are going to subtract it from the base number. This is always we have to do whatever value we get in the customized subnet mask, we have to subtract that value. So minus and you get 16. 16 is the range of the subnet. It means to divide, this is the range you have got of the subnet. Your subnet will be divided into range of 16. The addresses will be in the range of 16. This part clear to all of you? Okay, so now you got a range. Okay, again, see, let's see. You got 10, 0, 0. You got bits 4 by doing the formula 2 power to n minus 2, right? We wanted 10 subnets. Okay, so we got n is equal to 4. What we did? 10, 0, 0 is the default, class A. It has got IP 25500 default. Out of this, the first available 40 we converted as 1. Okay, so the value we got 240. This is the value by using the binary to decimal, right? So this is the customized subnet mask we got. The customized subnet mask value we have to subtract from 256 always. Whatever customized, it might be 240, it might be 192, it might be 224, it might be 128, it might be 248, 252, 254, whatever value we get, we have to always subtract it from 256. That is the base number. So after subtracting the value from the base number, whatever the value get is known as the range. This is known as the range. Okay. The range here of 16, you got a range of 16. This range we are going to implement in the subnetting. This is the design you are creating. This is the boundary you are creating. The range is nothing else but it is a boundary. Okay, it is a boundary. So let's see. So network ID is 10, 0, 0, 0. The customized subnet mask we have got 255.240.0.0 and range we have got of 16. So this is the information we have got. This is the by calculation we have got. Now we have to implement it into the subnets. So we'll do that. So first of all, this is your subnet number. Every subnet, as I already told you, you'll have a subnet ID. Network ID is 10.0.0. Okay, subnet ID you are having now. Subnet ID, after that you have got the valid IP hosts. Then in the end, you will have the broadcast IP or broadcast ID. All right. Now, subnet number 1, subnet number 2, subnet number 3, subnet number 4, subnet number 5, and so on. Now, what happens that theoretically you will always start with 16. Practically 0 to 15 will be valid also. Theoretically, in the exam and everything, you will start with the 16. Now, where are you going to use this subnet ID? Now we know the network is 10. Okay. Network is fixed. 10 is fixed. You cannot change this. After that, whatever the range we have got, what range we have got? 16. So I'm going to start with 16.00. This is my subnet ID. It means what? All the IP address in this subnet is going to start with 10.16. It will be 10.16.01, 10.16.02 like that. Got it? Now, the second subnet will be, network is same 10. What you have to do? Multiply the range with the subnet number. 16 2s are 32, right? Similarly here, sixteen fours are 64. 16 fives are 80. Okay. So the subnet ID is, I have written in a different color. So you know this has been changed. Why? You have to multiply the number here. This number is multiplied with the subnet number. The range you have to multiply with the subnet number. Is it clear? Now what happens after that? You are going to give the valid IP addresses. The valid IP addresses will be 10.16. It will always start with 16. In this subnet 1, actually in the real life, in the practically, it will start with 10.00 up to 10.15.0 like that. But here in this theoretical part, you are going to not write the first 0 to 15, but it is valid. Remember that. But in examination, in theoretically, you are always start with the 16. 16.0.1 will be the first IP here. The second IP will be 10.16.02. The third IP will be 10.16.03, 4, 5, 6, 7. It will reach till 10.16.0255. It will reach at 255. Once it reaches this part, reaches this 255, then 10.16.1.0 will start. Like say, this is 10.16.01. Then it will be 10.16.02 until it reaches as 255. Once it reaches 255, it will change to 10.16.1.0 and continue. It will go to 255. Once it reaches 255, this will change to 2. Then in 2, when it reaches to 0 to 255, this will convert to 3. So it will keep on moving until 10.31, 255, 254. Why 31? Because the next is starting at 32. So the broadcast ID here will be 10 10.31.255.255. Because after that 10.32 will start. Now here again I am going to, what is the IP here? First IP 10.32.0.1. Then it will end where? What will be the last address? 10.47.255.254. So broadcast ID will be 10.47.255.255. Now similarly here, what is the first IP will have? 10.48.0.1. What is the last IP? 10.63.255.254. And the broadcast ID will be, what is the broadcast ID here? 10.63.255.255. Got it? So this will continue until unless you get all the subnet. Now, what is the advantage of doing this subnet? As I told you, now whenever any machine between this range wants to communicate, they don't require the default gateway. Let's say the first IP address is always, it's a practice that given to the router, default gateway address. So 10.16.01 is the router. Now out of this range, for example, 10, let's say 24.3.8 wants to communicate with 10.40, sorry, 10 to 20, okay. It wants to communicate with 30.9.8. If they want to communicate with each other, and you know this is the subnet mask. So if you calculate, you'll find 240, it means range is 16, it means 24 and 30, they are in the same range. It means what? They are in the same subnet. So they don't require the router to communicate. Got it? They are talking in the same range. They are in the same network. They are in the same sub network. So that is why they are okay. When they are communicating, they are fine. Got it? So if they are not able to communicate, you are not going to check their default gateway address because they are in the same network. You will see whether any other problem is there. If any machine, two machines are not able to, say for example, I am calling Ashish, right? Ashish is not responding in the same class. It means he might be sleeping, right? Means he is not listening, he is sleeping. It means it is down. That machine is down in the same. But if I call Ashish who is in class C, I'm in class C, let's say class D. So if I say class D Ashish, if my voice is not going, it means what? My gate is having some problem. At the same time, I call here, so let's say I call Teja in class C. Teja is responding me. Ashish is not responding in the same class. It means there is no problem in my communication. Otherwise, Teja will also not respond. Ashish will not respond. Shreya will not respond. Right? Khushi will not respond. Or any, here what will happen, it is not going to, if we are in the same class, if nobody is responding, it means there is a problem in my voice. I am down. But if suppose one people is responding or not responding, all the other people respond, it means that person is having problem. But if I am able to communicate with every person in the class, but not any other person in the other room, and all of you are able to communicate with the other person in other room, only I am not able to communicate outside, it means what? There is a problem in my default gateway address. Maybe it is wrong address is given. Got it? So I'll check if you are able to communicate with the same default gateway, default gateway address, and I'm not able to communicate, so I'll check the default gateway address of mine. If not all of us are able to communicate outside, it means what? The router has got some issue. It might be down, it might be not accepting us to go outside, the link might be down, the destination might not be accepting, there might be many other factors. Is it clear the troubleshooting steps? Always whenever you are communicating inside your subnetwork, check whether if you are not able to communicate, check with the other machines. If you are able to communicate with all but not one, then there could be problem with that machine only. If you are not able to communicate with anyone inside your network, then problem could be inside your machine. If all of you are able to communicate to the other machine in the network, other network, not in your subnetwork, and only you are not able to communicate outside, means your default gateway address has got the issue, or they have blocked you, or all of us are not able to communicate anyone outside. It means either our router has got issue, or route is wrong, or everyone is blocked from this room. Got it? These are the logical steps to troubleshoot. Is it clear to all of you? Right? So now, because when they are in the same subnetwork, if they communicate, fine. If they cannot communicate or troubleshoot within the subnetwork. Now, but let's say 10.24.3.8 says, I want to communicate with 10.37.3.9. So as soon as 10.24.3.8 will say, I want to communicate with this, right? 10. So what is going to happen? It will calculate 240 because subnet mask. It will say, okay, this is in this subnet. It means it will go to the router. Let's say our router address is 10.16.01. So it will go to the router. Router will go to the router of this and say they have got router. This is the router, and then they will communicate. If they are not in the same network, same subnetwork. Got it? Is it clear? So if they are not in the same range, the router will come in the picture. Again, you will troubleshoot like this only. This part is clear to all of you? Any question here? Any query? Okay. What if the router gives the wrong direction? So router you are going to rectify. If the router you have given wrong, see if the router is giving wrong direction, so it will give to everyone, not only to you. If I am giving wrong information on the router, router will give the wrong information to everyone, right? It will not only for specifically for you. You might be blocked. There is something on an access control list. You might be blocked. That is one possibility. If you are not blocked, everyone else is able to access everyone outside except you. So you might be blocked. Your default gateway address is wrong. This could be two possibilities. Or the destination network has blocked you. Got it? So let's say another example for class B. It will be more clear. Okay, the broadcast ID we gave. We gave the broadcast ID 255.255. So 255 is the last address, is always for the broadcast. I told you broadcast is like a broadcast inside your subnetwork, which will not go outside. Although we are part of, for the full network, like I gave the example of India, 255, 255, 255, 255 is a broadcast from Delhi, from President or Prime Minister. But in your subnet, in the state, you have got your chief minister or your governor is giving a message to everyone, which will be only in your state. So that the broadcast ID for the subnet. So it is always the last address. So last address is always 255. The range finishes at 255. So 255, before 255, what we get? 254. So that is the last IP address given to the last machine. Let's say class B example. Now your boss, your administrator, your manager has given this IP and tells you that please create a subnet. I mean total we want, let's say 48 subnets. Got? So again we are going to use the same formula, 2 power to n minus 2 greater than equal to number of desired subnets. So here 2 power 2 n minus 2 greater than equal to, we want 48. So what will be the value of n? If I take 2 power to 0, it is 1. If I take 2 power to 1, it is 2. If I take 2 power to 2, it is 4. Take 2 power to 3, it is 8. It is 2 power to 4, it is 16. 2 power to 5, 32. 2 power to 6, 64. 2 power to 7, 128. So I'll take 2 power to 6 because I want 48. Either I take 5, so it will be 32. I don't want 32. I want minimum 48. So I'll take 2 power to 6, right? 2 power to 6. The value of n is 6. Now what I'm going to do, I have got 172, 16, 0, 0. And the subnet mask default is 255, 255, 0, 0. This is the default subnet mask class B. So now I'm going to convert binary to decimal for that. Now I'm going to convert 6 zeros as 1 here. Why? Because the value of n I have got 6. So 1, 2, 3, 4, 5, 6, 7, 8. Now the value will be 255. This is my customized subnet mask. So total 6. If I convert binary to decimal, I will get 252. You can check that. You can use the calculator also, or you can use the formula to convert the method which I showed you. This is the customized subnet mask. So the customized subnet mask, what value I've got? 252, right? So what I'm going to do, what is my base number? The default base number is 256. I'm going to subtract 252 from the 256. The value I get is 4. The range of my IP address, the subnet will be 4. Got it? Now let's convert. Let's implement this. File new. So 172.16.00 subnet mask I got 255.255.252 0. Range I have got 4, right? Now I have got this information now. So again I'm going to subnet number, subnet ID, valid host IDs or IPs or ID, whatever, right? And broadcast ID. Now here, what is the first? This subnet number 1, this subnet number 2, subnet 3, subnet 4. I'll just write. I'm not going to write all 14. Again here, practically we can use 0 to 4, but 0 to 3, but theoretically we are going to write like this. So it will be 172.16 and it will start with 4. So 4.0 is the subnet ID. Now here second will be 172. 172.16, 4 to the 8. So 8.0, because it is the second subnet number, we multiply 4 multiplied by 2. Okay, we are going to multiply with 4 multiplied by 2. Okay, so 172.16, then it will be 12.0. Now the fourth one will be, again remember, you are multiplying the range to the subnet number. You are multiplying the range to the subnet number. 16.0, and this will be 172.20 16 dot 20.0, right? Now the what is the valid host IP we'll have here now? It will start with 172.16 dot 4.1, right? Then it will be, so 172.16 4.1 2 3 4, it will go to 255. 4 will turn into 5, 1 0 1 2 3 4 5. So ultimately it will reach at 172.16 dot, very good, 7.254. Okay, because the broadcast ID will be 172.16.7.255. Got it? Similarly, this also 172.16 dot. Now this will start with the 8.1, right? It will go up till 172.16, 8, 1, 2, 3, 4, 5, like that. It will go up till 11. 172.16, 11.254. Okay, here also 172.16.12.1 up till 172.16.15.254. So I given this run. Now here 172.16.11.255. Here it will be 172.16.15.255. Got it? So here you can see you got less addresses compared to class A. In the previous example, it was huge in every subnet. Here also, all the machines falling under this range, they are in the same subnet. So they don't require any, like say, let's say 6.2 wants to communicate with 7.9. So they're in the same range. But if 6.2 wants to communicate with, let's say, 14.3, so it is in the other range. So it needs a router. Usually best practice is always your first IP address is given to router, second is given to your DC, third is given to your DNS, like that it goes, DHCP5, like this it goes for every subnet. Okay, this is for the best practice, not a hard and fast rule, but usually easy to configure. This is clear? Let's see one more example, class C, the last example. Yes. Class C. Now class C, your manager, boss, your whatever, they have given you this ID and they tell you that create a network of let's say 18 subnets. All right. So again the same formula, 2 power to n minus 2 greater than equal to number of desired subnets so 2 power to n minus 2, we want 18. So value of n will be again 2 power to 4 is 16. So 2 power to 5 is 32. So I'll take n is equal to 5. Now I'll take 192, 168, 1.0. So default subnet mask for class A is, first I'll let the default subnet mask. Then convert this value into binary. Now we want 5. So out of 5 zeros, we will mask or will convert as 1. 1, 2, 3, 4, 5, 6, 7, 8. Now if I convert, I get 255, 255, 255. Now here got 5 ones. It means what? It is 252. 252, right? Yeah. No, 250, 248. Okay, 248. Yes. So 248, this is the customized subnet mask. Customized subnet mask. Now we are going to subtract this from 256. What we are going to subtract? 248. What we get? 8. So the range we have got is 8. Right? We are going to use this information. So what we have got in our hand? 192.168.1.0 with a customized subnet mask of 255.255.248 with the range of 8, right? So we're going to do the same thing. Subnet number subnet ID valid host ID So subnet number, I'll start with 1, 2, 3, 4, 5. Subnet ID, what is the subnet ID here? 192.168. So because range is 8, right? So I'm going to start 192.168. 1 is the fix and the range is 8, right? So this will be 8. Now the second will be 192.168 1.16 because 2 8s are 8 2s are 16. Then 24, right? 32, 40, got it? Now valid host IPs will write as 9. 8, after 8 you got 9. It will end where? It will end at 15. There will be no dot after, there will be no 4th octet. Why? Broadcast ID will be, sorry, it will be 14, I'm sorry, 14. It will be 14, not 15, this is wrong. So this is, this will come as not 60, this will be 15. Okay. Now broadcast ID as the broadcast ID is always last. The IP address of your full range will, the last address will be broadcast ID. the first address will be the subnet ID. That's the rule. Okay. So we got broadcast ID is the first IP and the last IP, and the subnet ID is the first IP. That's the rule. So all the IP address in between will be there. So now here we are going to have, it will start at 17, it will end at 20, 22, very good. So we got 22 here, and the end it will be 23. The broadcast ID and subnet ID, we can't do anything. It's already there. You cannot give this IP address to the machine. You got, this is the range. We cannot change. So once you are using this range, 255, 255, 255, 248, so automatically it will take the first as the subnet ID, the last as the broadcast ID. You cannot give this address to any, it's automatically. Remaining inside, we can give it to the multiple computers. So this will be 25, and the last here will be 30, right? Because it will be 31, correct? So you can see you got very less number of IP address in the class C. How many? 17 to 22, how many? Only 6. 6 valid address, only 6 valid address. Now if you convert this into binary, you will see how many zeros we are having here from the right hand side? 3. 2 power to 3. 2 power to 3 is 8 minus 2. How many addresses we are having here? So the number of hosts is always 2 power to number of zeros minus 2. Got it? So if you calculate 9 to 14 is 6. 17 to 22 is 6. 25. So if someone asks you to get the number of hosts, so use the same formula, but convert from the right hand side, convert zeros. The remaining will be 1. Suppose they say we want 8 hosts in the class C. So what you're going to do, you're going to put 3 as 0, the remaining as 1. Got it? So you get this value here. This is clear to all of you? Any question, any query? Now I will show you, I will give you some subnet workbook. Now you might have, you might have exhausted also, because around 2 hours to 2 hours and 15 minutes we are doing this. So you might be exhausted also. But you see, this is very interesting and very useful. And you need at least 2 days from now to practice this. More you practice, then only you'll understand. And I will suggest to use this video again and again. And just give me 5-minute break. We'll take a 5-minute break. And then I will show you, there is a subnet workbook which I'll upload into the drive. I will show how to use it. Okay? So take a 5-minute break. This is the workbook which I'll be uploading into the drive for you to practice. Now, if you do this workbook properly, so you'll become master in subnetting. That is for sure. See here, what you can do, you can use a pen or paper also as an assignment, I can say, or you can directly, if you can write in the PDF, you can write here also. See here, they have given all like class range. 127 is for loopback. Okay. These are the private address space as we discussed. Default subnet mask for class. How to convert binary to decimal. So you can try these things as an assignment. Decimal to binary. Now you have to write the address. Now this is class A, right? 150 class B. 192 you write class C. So write like class C, right? This is 148. 148 is class B. This is 193, class C. 126 class A. Like this you will fill it. Okay. Then network host. Out of this, what is the network? What is the host? So this, as you can see, this is the, you can see the network portion because this is class B. This is the host in class A. This is all the host. Now this is class C. So this is the network. This is class C. So this is the host. This is class C. So this part is network. This is class C. So this part is host. This is class A. So this is the network. Class A. This is the host portion. Class C. This is the network portion. Class A. So this is the host portion. Like that you will identify. This for practice. So more you practice. Now default subnet mask. Now this is what? Class B. So the default subnet mask 255.255.0.0. Right? This is class C 223. So default subnet mask 255.255.255.0 like this. This is A. So 255. This is for practice purpose. Now this is another method and or. So we didn't use this method. We use the 2 power to n that method, right? So you are comfortable with this also you can do, else you can follow my method which I showed you. Now here they get the problem, number of subnet we want 14, number of hosts we want 14, network address 192.10.10.0. So the default subnet mask class C will write, custom subnet mask you calculate. So here you can say, if you see let's say right, let's say here. If I say here 2 power to n minus 2, how much subnet I want? 14, right? Correct? So 2 power to n 14. So the value of n will be 4, right? So it means what? This is the default subnet mask. It means 4, 0. I convert this 4 here as 1, 2, 3, 4, 5, 6, 7, 8. Here I do that, right? 4. Now if you see here, we need the host also 14. So from the right hand side, if I take 4, 0, this also satisfies this equation. Got it? Now if you convert 240, so 240 means 256 minus 240, what is the range you get? 16. You can see 16. Usable subnet 14, 16 minus 2. Right? Theoretically it is 16 minus 2. Practically you will have 16. Usable address again 14 because there will be minus 2. Number of bits borrowed, 4 bits we took, right? N is equal to 4. Got it? Similarly, you will do the same thing, host. Now here they are talking about host only, right? So if I take 2 power to n minus 2 equal to number of hosts is 60. So 60, for 60 what I want, n is equal to 6, right? So 6 bit will be off. Out of this, these are class B, so default is 6, right? So what I'm going to do here is, from the right hand side, there will be 6 zeros. So left hand side, you got 18, total 16, 8 here, 8 here. So out of this, 8, 8, 6 will be 0. So remaining will be 1, right? Got it? You got this thing? See, 6 are here, right? We want 6, 0. From the right hand side, if we take 6, 0, so the remaining will be 1. If you convert, we get 192. So number of bits borrowed here is 10. Okay, how 10? Yeah. So actually it is 8 here and 2 here. 8 1, subnet also 1000. So if we take 1000, so 2 power to 10, or host also we can do the same thing, you get the same result. So number of host is 64, 2 power to 6 is 64. Got it? 64 minus 2 is 62. Got it? Number of subnet 1024, 2 power to 10 is 1024, minus 2 1022. So you can do this all. See, they have given examples. After that they want you to give. So this is class C. Default subnet mask, right? Now custom subnet mask, so this is 6, so 2 power to n minus 2 greater than or equal to 6, so 2 power to 3, right? So 2 power to 3 if I take, so here 3 0 will be converted to 3 1, right? Here it will be 1 1 1, right? This will be what? 255, 255, 255, 224, correct? How many subnet we are getting? 2 power to 3, that is 8. How many usable subnet? 8 minus 2, 6, right? How many addresses we are getting? 2 power to 5, that is 2 power to 5 is how much? 2 power to 5 is 32. Number of usable addresses we are getting? 32 minus 2 equal to 30. Bits borrowed 3. Is it clear? Two power to 3 is 8 minus 2 6. So only 6 we are getting. So range is from 224. 32 is the range. So 0 to 31 is the first subnet, which is practically. That is why it is saying usable subnet in theoretically. So 0 to 31 in practically we are using, but here only 6 we are using. Got it? What is your question? That is why I am saying 2 power to 3 is 8. 8 minus 2 is 6. You are using only 6 subnet. The other remaining 0 to 31, theoretically you are not using. And the last one, which reaches to 255, you are not using theoretically. Practically you are using. Got it? Usable subnet, when it say you are taking this formula. Clear? Same you can continue. All the problems you will solve. Subnetting then here also, don't subnet here. Now here, what is the third usable subnet? So as you can see, it is 16, right? 240 means the range is 256 minus 240, which gives you 16. So third usable subnet 16 multiplied by 3 is 48, correct? And 63, because the next will be 16 4s are 64, so it will come to 63, 48 to 63, and 48 is the subnet ID and the 63 is the broadcast ID. So actual IP you get 49 to 62, right? 8th also, 12th usable, like that. So again you have got calculation that done, we can do our own calculations. So this second usable subnet, number of bits per hour, first usable. So you are going to solve these all as an assignment. Solve the problems. I'm going to upload this into the drive now only, so you can check in your days. valid, non-valid. 0, network ID cannot be 0, right? 192 fine. 245 not valid address because it's a class D address, not valid. 135 fine. You can check the subnet mask also, you can check everything. Valid, non-valid is right here. This class A addressing, so subnet mask for total number subnet. This is already given for that. If you want, you can use this also, or you can use the formula also. Okay. So I'm going to upload this and you can practice this. So give me 2 minutes, I'll upload this one.